The sequence of numbers is called a geometric progression if each number, starting from the second, differs from the previous one in a certain number of times. And this number will be a general ratio between the terms of the geometric progression. If we multiply the first term of the geometric progression by this number, then we get the second term of the geometric progression. We multiply the second term of the geometric progression by this number, we get the third term of the geometric progression. And so on. I multiply the second term of the geometric progression by r, I get the third term of the geometric progression. I multiply the third term of the geometric progression by r, I get the fourth term of the geometric progression. I write down r multiplied by itself 3 times as a power with an exponent of 3. Here the exponent will be 2. And in general, in order to find the nth term of the geometric progression, I need the first term of the geometric progression to be multiplied by r. And the exponent for r will be 1 less than n. If I divide the two closest terms of the progression, then I will get the general ratio between the terms of the geometric progression. The only thing to remember is that we divide the term of the progression with a larger index by the term of the progression with a smaller index. If the number r is a positive number, then all the terms of the geometric progression will be either positive numbers or negative numbers. Everything will depend on the first term of the geometric progression. If this number is positive, then when multiplying a positive number by a positive number, we will always get positive numbers. If this number is negative, then when multiplying a negative number by a positive number, we will always get negative numbers. If the number r is negative, then the terms of the geometric progression will alternate between positive and negative, or vice versa, negative and positive. Everything will also depend on the first term of the geometric progression. This is due to the fact that when multiplying two negative numbers, the result will be a positive number. And when multiplying a negative number by a positive number, or vice versa, the result will be a negative number. So here, if the number a is a positive number, we multiply a positive number by a negative number, the result will be a negative number. Then we multiply a negative number by a negative number, we get a positive number, and so on. If the general relationship between the terms of the geometric progression is in the range from -1 to +1, of course, here the number 0 is not considered, then the progression with such a number r will be infinitely decreasing. This is a topic of a separate lesson. The link to the lesson is in the description. Now I will write down the sum of the first n terms of the geometric progression. This is the nth term of the geometric progression. Now I will multiply each term of this equality by r. And in those elements where r is present in some power, the power of r will increase by 1. Here the exponent will be equal to 4, and in the last term, the exponent will be equal to n. And now I will subtract these two equalities term by term. In the left part, I will get the expression, and on the right side, the terms will cancel out. Then the terms with the second power will be reduced. Then the terms with the third power, and so on. And the term with the power of RT1 minus 1 will also be reduced with the penultimate addition here. And only A1 will remain multiplied by R to the power of n. From the first expression in the right part, from the second expression in the right part, the first term of the geometric progression remains. We subtract and factor out the sum of the first n terms of the geometric progression from the left side as a common factor. What remains in the brackets is r minus 1. On the right side, we factor out first term of the geometric progression, leaving r to the power of n minus 1 in the brackets. Divide the left part and the right part of this equality by r minus 1. So that in the left part, I have only the sum of the first n terms of the geometric progression. Let's find the seventh term of the geometric progression. First, try to solve this problem yourself. Pause the video. And I show the solution. I substitute the numbers in the formula. Here n will be equal to 7. 16 is equal to 2 to the fourth power. Now the numerator and denominator of the fraction I will raise to the sixth power. 1 to the sixth power will remain 1. 2 to the fourth power I will write in the denominator of the fraction. At the same time, I need to replace the exponent indicator with its opposite one. Here we have a positive 4. In the denominator there will be a negative 4. I multiply the numerators and denominators. In the denominator I subtract 4 from 6. I get the exponent of 2. So I get 1/4. Let's find the sum of the first 4 terms of the geometric progression. If I multiply the second term of the geometric progression by the general relationship of the geometric progression, I get the third term of the geometric progression. If I multiply by r again, I get the fourth term of the geometric progression. I divide the left and right parts of the equality by the second term of the geometric progression. And I write r multiplied by r as r to the second power. I substitute the numbers. And now I need to solve the simplest square equation. And since r is a positive number, I only need a positive solution of the square equation. I divide the second term of the geometric progression by the general ratio of the geometric progression. I get the first term of the geometric progression. And now I will use the formula. N will be equal to 4. Let's look at the numerator separately. I will write 7 to the fourth power as 7 to the second power, and again to the second power. Let me remind you of the formula for the difference of squares of numbers. And let's apply this formula. And to the first expression in brackets, let's apply this formula again. Let's substitute this expression instead of the numerator. The first expression in brackets and the denominator cancelled out. 50 multiplied by 2 is 100 and multiplied by 8. So, we get the sum of the first 4 terms of the geometric progression. That's all for today. Bye everyone.